Welcome to the multiplying and dividing radical expressions lesson. We're going to split this into two parts. So in this video, I'm going to focus more on multiplying radical expressions, and then the next video we'll talk about dividing radical expressions. So when multiplying radicals, you're going to multiply the coefficients and just the coefficients, and then multiply the radicands. And you can only multiply radicals if you have the same index. And you cannot do it otherwise. So that means if you have a square root of 2 multiplied by square root of 2, that is fine. But if you have the square root of 2 multiplied by the cube root of 2, then you can't multiply them together. Alright, so for example, root 3 times root 5, we have the same index, which is square rooting. Our radicand is 3 and 5, so we're just going to multiply the radicands together. That's 3 times 5, which is 15, and you leave the square root alone. Let's try the next one. So in this case, we have coefficients in the front, so we're going to multiply the coefficients and then multiply the radicands after. So your coefficient is 2 times 3, so you have a coefficient of 6, and then afterwards we're going to multiply the root 3 times the root 3. 3 times 3 is 9. You leave the root alone. But we know what the square root of 9 is. Square root of 9 is 3. So 6 times 3 is 18, and that would be our final answer. Let's do a lot more of examples on this. So for part A, we have root 2 times root 6. We leave the square root alone. Then we multiply the inside, so it's the radicand, so it's 2 times 6 is 12. We also are going to simplify, so I'm going to write this into a mixed radical. I'm going to separate 12 and rewrite this as 4 times 3 instead, because I can take the square root of 4. The square root of 4 is 2. I'm going to leave the root 3 alone. Moving on to the next one. We have root 3 times root 3 minus root 7. So I'm going to multiply this root 3 with the root 3 inside the bracket, and then also multiply it by negative root 7. So for our first round rainbows, root 3 times root 3 is root 9. Root 3 times root 7, we'll leave the square root of alone, and then 3 times 7 is 21. We do know what the square root of 9 is. And that is 3. I'm going to leave the root 21 alone just because we can't simplify that any further. Moving on to C, we're going to multiply these like we usually would when we multiply two binomials together. So the order looks like this. I'm going to multiply 4 root 2 with 3 root 2, and also 4 root 2 with negative root 5. Then I'd go to the second term, 2 root 5 multiplied by 3 root 2, and 2 root 5 multiplied by negative root 5. So for the first set, that's 4 times 3. This will give us a coefficient, which is 12. Then we're going to multiply our radicands together. Root 2 times root 2 is root 4. I'm going to leave that right now, and we can simplify this later. The next one we're going to do is 4 times negative 1. Remember, the 1 there is invisible, so that would give us negative 4. And then multiplying the radicands is root 2 times root 5. That's root 10. Our next set, we have 2 times 3 for coefficients, that's 6. And then root 5 times root 2 is root 10. Then our last pair we're going to multiply. We have 2 times negative 1, which is negative 2, and then root 5 times root 5, which is root 25. Now we can go ahead and simplify. So root of 4 is 2. For 4 root 10, we can't simplify it, but we can combine like terms afterwards. And then we have 2 times root 25. Root 25 is 5. 12 times 2 is 24. We can combine these because they're like terms, We both have that root 10 there, so we're going to subtract negative 4 plus 6, which is positive 2 root 10. We leave the root 10 alone. Then lastly, 2 times 5, we have a negative in front, that's negative 10, and then lastly we're going to do 24 minus 10, so that's 14. That would be our final answer. So we're going to do this one more time here. Same sort of concept, but if you take a look at what we have for our binomials, we have a difference of squares. Okay, so when that happens, we know that it's going to simplify pretty nicely every time we have a difference of squares. So let's go ahead and do this. So 4 times 4 is 16. Okay, so that's coming from here. Then root 2 times root 2 is root 4. Moving on to the next set, 4 times negative 2 is negative 8. Then root 2 times root 3 is root 6. Then our next set, we're going to do 2 root 3 times 4 root 2. So 2 times 4 is 8. Root 3 times root 2 is root 6. Then lastly, we have 2 root 3 times negative 2 root 3. So 2 times negative 2 is negative 4, and root 3 times root 3 is root 9. So let's simplify this. The root of 4 is 2. This cancels out. Negative 8 root 6 plus 8 root 6 cancels out. And then root 9 is 3. 16 times 2 is 32. 4 times 3 is 12. So 32 minus 12 is 20, and that's our final answer. Now we're going to move on to looking at variables inside the radicand. So we have to identify the values of the variables for which the expression is defined, because we know that we can't have negative numbers inside our root sign, meaning we can't take the square root of negative numbers. We also need to state any restrictions on the variables, and it has to be determined from the original expression, the original one. So why are there no radicals in your answer for D? Again, that's because this is a difference of squares, so it takes on a similar format to this, where our x in this case was 4 root 2 and y was 2 root 3. So for example 2, we're going to simplify and identify any values of variables for which each expression is defined. And these, you can tell, this first one here is the perfect square, this A1. So we're going to define that x has to be greater or equal to 0. We can't have any negatives inside of our root sign. We can't take the square root of negative numbers. And then we're going to follow the same process as what we've done before. 2 times root x multiplied by 2 times root x. This is 4 root x squared. Then we have 2 root x times negative 5. Negative 5 times 2 is negative 10. And then we leave the root x alone. Then we have 5 times 2 root x. Again, we get 10 root x, but this time is positive. And lastly, 5 times negative 5 is negative 25. So we're going to simplify this now. The square root of x squared, their square root and their square is going to cancel, so we're just going to be left with x. Also, negative 10x, negative 10 root x, and positive 10x root x is canceled out, so that's gone, and then we're just left with negative 25. Moving on to B, so we're going to multiply again by using our rainbows or FOIL. So 7 times 3 is 21. 7 times negative 5 root b, that's negative 35 root b. 2 root b times 3 is positive 6 root b. And lastly, 2 root b times negative 5 root b is negative 10. b multiplied by b is b squared. So let's go ahead and simplify this. Negative 35 root b plus 6 root b. So negative 35 plus 6 is negative 29. That's our coefficient. We leave the root b alone because we are adding. Then the square root of b squared. Our square root and our square cancels out, so we're just left with b. That would be our final answer, but don't forget about your restriction. Remember to look at the original to see what our restriction is. So b here, again, has to be greater or equal to 0 because we can't have a negative square root. Lastly, for c, it's a long one, so we are going to take some time to do this. For x and y, from the beginning, we can tell that both of them have to be greater or equal to 0, so that is our restriction. Looking at this over here, I'm going to rewrite this whole thing so it looks like I am multiplying. Do not put this square into here like this. That is so wrong. Okay, so that's why I'm rewriting everything again, so we can follow the right rules. So we have root x plus 5 root y times root x plus 5 root y. Remember, when you're squaring, you're multiplying that thing by itself twice. All right, so now we're going to go through all of this and multiply it out. Step by step, though, because it is pretty lengthy. We're going to do 3 root x multiplied by 3 root x first. 3 times 3 is 9. Root x times root x is just x. So I'm doing a shortcut now that I know that if I take root x times root x, I'm just going to get back x, because that's the root of x squared. Just as a shortcut now. Now we have 3 root x multiplied by negative root y. Our coefficient is negative 3, coming from the 3 and the negative 1, and then we're going to multiply x and y for the radicand part. Next we have root y times 3 root x, which is positive 3 root xy, and then we have root y times negative root y, which is just negative y. So that one's done. Moving on to the next one. Remember to keep your bracket here. This negative will affect everything inside the bracket afterwards. Okay, so I'm going to do root x times root x, which is just x. Then we have root x times 5 root y, which is 5 root xy. Then we have 5 root x, 5 root y, multiplied by root x, which again is 5 root xy. Then lastly, we have 5 root y multiplied by 5 root y, which is 25y. That's because we have 5 times 5, so that's from our coefficients, and then root y times root y is y, or in other words, the square root of y squared. Let's try to simplify a couple of things. So we can tell that these are gone, plus 3 root xy minus 3 root xy is just 0. So I'm just left with 9x minus y here. I'm going to also distribute this negative to every single term. So then we have, I'm going to make myself a bit more room here. So then we have negative x, negative 10xy, negative 25y. So what I just did is kind of combine my 5 root xy with the 5 root xy. We just add the coefficients together and leave the radicand alone because we're adding. And then lastly, I'm going to collect my like terms. So we have 9x minus x, which is 8x. We leave the 10 root xy alone, And then we have negative y minus 25y, which is negative 26.